How large is 5% growth over 6 years? What about 10 years? You need to find the answers quickly in order to succeed in PST. Luckily, there is an approximation technique which we'll be able to use to help us cut the time solving this question. And this is what the 6th session of the problem-solving test course will be dedicated to. And some examples will illustrate the theory. Let us start with the following example. You might want to pause the video now and try to solve the question on your own. Which of the following is the closest estimate in billions of dollars of the projected revenue of ABC Industries in 5 years in the upside case? From the text, we learned that the revenue of ABC Industries now is $11.64 billion. And in the upside case, the revenue growth is projected at 7% per annum. Revenue in year 0 equals 11.64 billion. Growth in the upside case equals 7%. Revenue in year 5 equals revenue in year 0 times 1 plus the growth rate in the upside case to the power 5, because we are looking at the 5-year horizon. And using numbers, this would look like 11.64 times 1 plus 7% to the power 5. Okay, the straightforward way of solving this question would look like this. We would need to write things down again and do the lengthy multiplication. Well, of course, this calculation is solvable, but I think I would need to spend about 15 minutes trying to tackle it. And of course, I cannot afford to do that in a real PST setting. So another way of solving this question would be through a roundabout called compound margin. We can write our compound growth statement in terms of simple growth plus something else. This something else is called the compound margin, and in this case its value would be about 5 or 6%. In this theory session I will explain to you how I got this number. So the result would be roughly 11.64 times 1.4. And then the calculation becomes quite easy, right? And so we are ready to pick our option here. Our choice is B. Let us look at the mechanics of compound growth approximation. We are in this compound growth situation, which is so difficult to compute, and we want to transition to simple growth. The question is, how do we do it? Binomial expansion is a way of representing a sum of two values in the nth power via a sum of their powers from 0 to n, with certain binomial coefficients. The expression might seem a bit overcomplicated at this point, but in our special case it becomes straightforward. Well, indeed, the first summand is just 1, the second is an x, and everything that follows is a small number whenever the absolute value of x is smaller than 1. So we can rewrite our compound growth expression in the following way. Compound growth equals simple growth plus a certain small number called compound margin. To make the compound growth expression operational, we need a better understanding of how the compound margin behaves. I computed the values of the compound margin for different growth rates x and numbers of years n, and here's what I got. Green cells indicate values up to 10 percentage points, and red values indicate values above 200 percentage points. A few interesting observations. Firstly, the compound margin is always positive, even when the growth rate is negative. This is explained by the fact that in the expression for compound margin, even powers of x are always positive and outweigh subsequent odd powers of x, which might be negative. Secondly, when the growth rate and the number of years are small, the compound margin is small too, typically below 10 percentage points. But the compound margin shoots for the stars when x and n become large. So we cannot neglect it when x and n are bigger than about 10. Let's write these properties down and see why they matter. Compound margin greater than 0 means that the compound result is always greater than the simple result. In other words, a compound growth is higher than simple growth, while a compound decline is smaller than simple decline. Here's an example. 1 plus 5% to the power 7 equals 1 plus 35% through simple growth plus compound margin. And the result is about 1.4, which is greater than the result from the simple growth. So the growth is bigger in the compound growth case than in the simple growth case. Now let's look at a decline example. 1 minus 5% to the power 7 equals 1 minus 35% plus, again, compound margin. And the result is about 0.7, which is again greater than the simple growth result, or simple decline result, of 0.65. So the drop is smaller in the compound decline case than in the simple decline case. Another interesting result is that when x times n is less than or equal to 45 in absolute value, the compound margin does not exceed 10%. So, for example, 1 plus 6% to the power 7 equals 1.42 plus compound margin, which is about 150. So the compound margin here is about 8%, less than 10. However, in the case 1 plus 6% to the power 7, the result will be different. And the compound margin here is about 19%, which is greater than 10%. And here's a more extreme example. 1 plus 6% to the power 20. So in this case, the compound margin is 101%, which is greater than 10%. Much greater, actually. So we see that when x and n are small, then the compound margin is small. But when x or n together get quite large, compound margin is growing as well. And it can grow to huge numbers way above the simple growth. Let us apply this new knowledge to an official practice question. As always, you might want to pause the video now and attempt the question on your own, and then check. By the way, we've done this question in our first practice session. And I would immediately cross out C and D just because they're not very interesting. The interesting options here are A and B, because now we will be able to check them. So we need to find a valid conclusion based on the data in table 1. A. Revenue for other products was more than 20 million 5 years ago. Other products, now it's 15.1 million, and the decline was about 7% per annum. Let's say that X is the revenue for other products 5 years ago. Then the following would hold true. This expression is a translation of the option A from English into math language. Recall that the compound margin is always positive. But in this case, because 7 times 5 is less than 45, I would say that the compound margin here would be quite small, probably about 2%. So our result would be roughly x times 1 minus 33% equals 15.1, or 2/3 of x equals 15.1. But in this case, obviously x is larger than 14 instead of 15, because it's easier to compute, over 2 times 3, or 21. And 21 is greater than 20. So that means that option A is actually true. In a real PST setting, once we know that A is true, we would stop solving this question and continue to other questions, right? But here, for the sake of instruction, let's consider option B as well. Because here, too, compound margin will help us deal with it. Hot dog revenue was more than 350 million 5 years ago. Hot dog revenue this year 366, and the annual growth was 4.2. So again, here we translate English into math. And again, let's say that X is the revenue of all beef hot dogs 5 years ago. We know that the contribution margin here is greater than 0, but it should be quite small. I think it would be about 1 to 2%. So our result would be approximately 366.7 over 123, which is less than 366.7 over 1.2. So that means that B is false, and we can cross it out. Now here's another interesting example from an official PST practice test. Again, pause the video and try to solve the question on your own. Assuming housing starts declined at a constant rate, which of the following is the closest estimate of the annual percentage drop in the number of first quarter housing starts between 3 years ago and this year? So the value for 3 years ago was this number, 2,150,000. This year the value is here. The value is about 500,000. So let's assume that X is the desired annual percentage drop. Now let's translate the question from English into math language. 2,150,000 times 1 minus X% to the power of 3, because 3 years of decline, equals 500,000K. Let's simplify this a bit. 1 minus X% to the power of 3 is roughly 1/4. Let's test our options now. A. But this is not possible because the compound margin is always greater than 0, and from here it should be negative. So we get rid of A because A is wrong. Let's test B in a similar way. Well, obviously B does not work either, right? Because from this expression we need the compound margin to be 0, and we know that the compound margin is always positive. So we get rid of B as well. C. So C might actually work, because here we see that the compound margin is positive, and also it's quite big. But that's okay because the decline rate is quite big as well. Let's test D instead. Let's take 50% instead of 55%. Then the result after 1 year would be 50% of the start. The result after 2 years would be 25%. And the result after 3 years would be 12.5%, which is obviously less than 0.25. That means that D is a huge decline. It's just too large for us. And we get rid of D as well. So the only plausible option here is C. And C is our answer. Let us synthesize what we have learned today. We express compound growth via simple growth plus a certain number called contribution margin. Contribution margin has two important properties. 1. It is always positive. 2. If X and N are sufficiently small, that means not exceeding 45 in absolute value, the compound margin is also small, not exceeding 10 percentage points. That's it for today. If you have any questions, as always, feel free to leave them in the comments below. I will be happy to answer. Thanks for watching, and until next time.